Okay, last video for 510 is actually going to be example 6. Kind of skipping over example 5. I will be honest with you. Maybe we'll do that one in class. Okay, so it says your job is to design. You can ignore this. We're actually going to do this one as an example. So your job is to design a right circle cylindrical, so a can that will hold 22 cubic inches of soft drink. However, you must conserve the amount of aluminum used in the can. So that's the surface area. And then what radius would give you a minimum surface area or conserve the cost of the can? So what are we given? We are given that the volume must be 22 inches cubed. So remember, volume is area of the circle times the height. So volume is pi r squared h. So 22 equals pi r squared h. Okay, surface area. So, and then what do we need to find is we need to minimize surface area. So surface area is the two circles, the top and the bottom, and the sides, which make a rectangle. Picture if you unrolled a can, the sides would be a rectangle, and this side length would be the circumference of the circle. So surface area of a cylinder is 2 pi r, so that's the circumference, times h. So that is the area of the sides, and then plus two circles. Area of the circle is pi r squared. So this is the area of the circles on the top and the bottom, and this is the area of the sides. So this is what I want to find the minimum of. But again, I have to write it in terms of a single variable. So go back to your given function and solve that for h. So h equals 22 over pi r squared. And then I'm going to substitute that into here. I'm also going to just start calling this area because I don't feel like writing surface area the whole time. So surface area will be 2 pi r times 22 over pi r squared. So substituting in for that h to get a single variable, plus 2 pi r squared. And then we can do a little simplifying here. So I have a pi on the top. Do I have pi on the top? Yeah, I do. I have an R, one R, two R's on the bottom, and one R on the top, and pi and pi. So I'm left with 44 over R plus 2 pi r squared. Okay, I'm going to write this as 44r to the negative 1 plus 2 pi r squared. Now let's find the derivative. So a prime would be negative 44 r to the negative 2 plus 4 pi r. R to the negative 1. Yes, r to the negative 2. Okay. It's a calculator one, I believe, because you end up getting a decimal. So I want to find out where this is equal to 0. So if you set this equal to 0 and graph this and find the zeros, you're going to find that a prime equals 0 at r equals 1.1519, and I should say approximately there. So remember, oops, I'm sorry. Let me slide that up. We want a minimum, so I want to verify that this is a minimum. And if I look at this derivative, I'm thinking I can do second derivative tests because this isn't too hard of a second derivative to take. So if I do second derivative, I'm going to get 88 r to the negative 3 plus 4 pi, which is 88 over r cubed plus 4 pi. So that will be positive everywhere, right? My radius is always going to be a positive number. So this will be positive everywhere, which means my area function is concave up, which means I do indeed have a minimum. So R equals this number right here, 1.1519, will give me the minimum area. So a radius of R equals 1 point, what was it? Oh, 1 point, oh, I don't think it's supposed to have a 1 in there. Sorry, this should just be 1.519. I copied that down wrong. So 1.519 gives smallest surface area. Okay. All right. Example 6. Kind of do this just in case you missed anything. Then you have the whole problem. You can pause it and copy whatever you missed.